Goal is to figure out how to read these graphs. So you need to understand what's going on here. So basically we have cart 1 and cart 2 represented with two different lines. Cart 1 and all of them has the triangles. So in graph 3, what's happening is the velocity of the cart is 0 meters per second. So we can see cart 1 and 2 are lined up here right along the 0. So this must mean two carts are just sitting at rest, facing each other, with a spring in between them probably. So they're at rest, and then someone hits the plunger and they separate and they move outward, and now cart 1 is moving up here at, if you go over and read it, it's between 6 and 8. So this is going 7 meters per second to the right, and this one down here is going 7 meters per second, and we know it's going the other way to the left. So this would be the way a cart explosion looks. So when we look at 32, which graph shows a cart explosion, we would definitely say graph 3, and then also graph 5, because it's got the same pattern. All right, so graph 5 would be a cart explosion. Which one shows an inelastic collision? That would be the other pictures, because here you can see cart 1 is going 10 meters per second, but then and here's another cart that's at 0 meters per second, cart 2. So what's happening is cart 1 is flying along, going this way, and it's going to hit cart 2 that's at rest. So when they hit, they stick together and they move onward. So they're connected and they move onward, and they are now going a speed of 5 meters per second. So this would be an inelastic collision. So graph 4 and 6. In which graphs are the masses of the cart equal? That would be when you have exactly the same speeds resulting. So when you have the same distance, right? If these guys were the same mass, you would expect them to go the same speed. So I would say graph 3, they're equal. And then I would say graph 4 also, because they started at 0 and 10 and they ended up at 5. Okay, but look at graphs 6 and 5 here. Do you see how the new resulting speed is not right down the middle? That's because one of the cars was more massive than the other. What is the change in velocity of cart 2 in graph 4? If we look at graph 4, it's right here. So what's the starting speed of cart 2? Cart 2, the initial speed of cart 2, remember that's the straight line, was 0. The final speed of cart 2 was 5. If we read this, it's right in between. So 5, so remember final velocity minus initial velocity equals change in velocity. So I would take 5 minus 0, so the change is 5 meters per second. And then the last question, if the cart has a mass of 0.5 kilograms, what's the momentum of cart 1 in graph 6 after the collision? So after the collision is here, cart 1 and 2 have the same velocity, which is 7. So we can say the velocity is 7 meters per second. If the mass is 0.5 kilograms, then just remember, momentum is m times v, so 0.5 times 7 turns out to be, it's going to be, 35, move the decimal over once, so 3.5 kilograms times meters per second.